Hello, I'm Essay, your AI essayist. Please note that all content, audio and video in this presentation are AI generated. As AI can sometimes produce inaccuracies, I encourage you to verify any factual information presented. With that in mind, let's begin.
Abu Ali al-Hasan ibn al Haytham, known in the West as Alhazen, stands as a monumental figure in the history of optics, mathematics, and astronomy. His magnum opus, the Book of Optics, completed circa 1021, represents a paradigm shift in the understanding of vision and light, moving decisively away from the ancient Greek emission theory towards a more accurate intromission model. This comprehensive treatise, originally composed in Arabic, consists of 7 volumes and delves into a wide array of topics, from the anatomy of the eye and the process of visual perception to the laws of reflection and refraction, and the nature of light itself. The Book of Optics is more than a compilation of existing knowledge. It presents a systematic and experimental approach to optical phenomena, establishing Ibn al Haytham as a pioneer of the scientific method centuries before its formal articulation in Europe. The intellectual landscape preceding Ibn al Haytham was dominated by a mixture of philosophical speculation and empirical observation. Greek thinkers such as Euclid and Ptolemy had made significant contributions to geometry and optics. Euclid, in his Optics, explored the geometry of vision, assuming that sight occurs by means of rays emitted from the eye. Ptolemy, in his own Optics, further elaborated on this emission theory, while also investigating refraction and colour. However, these early investigations lacked a rigorous experimental framework and often relied on idealized geometric models that did not fully capture the complexity of visual phenomena. The emission theory itself posed several conceptual difficulties. For instance, it struggled to explain why the eye could be overwhelmed by bright light, or how we could see objects as vast as stars, given the presumed weakness of visual rays. These limitations created an intellectual vacuum that Ibn al Haytham's work would. The Book of Optics opens with a detailed description of the anatomy and physiology of the eye, drawing upon the Galenic tradition, but also incorporating Ibn al Haytham's own anatomical investigations. He meticulously describes the different parts of the eye, including the cornea, lens, and retina, and their respective functions in the visual process. Crucially, Ibn al Haytham argues against the emission theory, proposing instead that vision occurs through the reception of light rays emanating from objects and entering the eye. This intromission theory, while anticipated by some earlier thinkers, was presented by Ibn al Haytham with unprecedented clarity and empirical support. A central theme in the Book of Optics pertains to visual perception. Ibn al Haytham argues that the eye is merely the instrument of vision, while the brain performs the crucial task of interpreting the visual information received. He identifies several factors that influence visual perception. This includes recognition of size, shape, distance, and color. He explains visual illusions and perceptual errors based on faulty judgment or misleading sensory information. His analysis of visual perception is remarkably sophisticated, prefiguring later developments in psychology and neuroscience. Volumes 4 through 6 of the Book of Optics are dedicated to the study of reflection and refraction. Ibn al Haytham meticulously investigates the laws governing these phenomena, employing geometric constructions and experimental techniques. He confirms the law of reflection, stating that the angle of incidence equals the angle of reflection. He systematically studies reflection from plane, spherical, cylindrical, and conical mirrors, both convex and concave. He analyzes the formation of images in these mirrors, determining the location, size, orientation of the Ibn al Haytham's work on refraction is equally impressive. He demonstrates that light rays bend as they pass from one medium to another of different density, such as from air to water. He performs experiments to measure the angles of incidence and refraction for various materials and angles. He attempts to discover the relationship between these angles and proposes several empirical laws. His laws are approximations of Snell's law, which was discovered independently by Willibrord Snellius in the 17th century. Ibn al Haytham's investigation of refraction leads him to study atmospheric refraction, explaining the apparent increase in the size of the sun and moon near the horizon. He also explores the phenomenon of the rainbow, attributing it to the combined effects of refraction and reflection in raindrops. Perhaps the most famous problem addressed in the Book of Optics is Alhazen's problem. Given a light source and a spherical mirror, find the point on the mirror where the light will reflect to a given observer. This problem leads to a quartic equation, a fourth-degree polynomial equation, which Ibn al Haytham solved geometrically using conic sections. The solution demonstrates his mastery of both geometry and optics and represents a significant achievement in applied mathematics. Ibn al Haytham's methodology distinguishes his work from that of his predecessors. He emphasizes the importance of empirical observation and experimentation. He articulates a clear procedure for scientific investigation. This involves formulating a hypothesis, testing it for experimentation, and then either confirming or rejecting the hypothesis based on the experimental results. He insists on mathematical rigor and logical deduction, carefully analyzing his experimental data and drawing conclusions. This approach, combining empirical observation with mathematical analysis, marks a turning point in the history of science and anticipates the scientific revolution of the 16th and 17th centuries. The immediate impact of the Book of Optics was significant. It rapidly disseminated throughout the Islamic world, influencing generations of scholars. His work on optics was translated into Latin in the 12th or 13th century. It exerted a profound influence on European scientists and scholars, including Roger Bacon, John Petcham, and Whitelaw. These scholars drew heavily from Ibn al Haytham's work in their own investigations of optics and vision. The Book of Optics stimulated further research in optics and contributed to the development of spectacles, telescopes, and microscopes. Later scientists and mathematicians built upon Ibn al Haytham's foundations. Johannes Kepler, in his work on optics, acknowledged his debt to Ibn al Haytham. Kepler used Ibn al Haytham's intromission theory of vision to explain the formation of images on the retina. Isaac Newton, in his optics, further developed the theory of light and colour, building upon Ibn al Haytham's experimental methods and observations. The wave theory of light, developed by Christian Huygens, also owes a debt to Ibn al Haytham's emphasis on the physical nature of light. The reception of the Book of Optics was not without its challenges. Some scholars initially resisted Ibn al Haytham's rejection of the emission theory, clinging to the established authority of the ancient Greeks. Others found his mathematical approach difficult to grasp, preferring more qualitative descriptions of optical phenomena. However, the overwhelming weight of experimental evidence and the logical rigor of his arguments eventually prevailed. The Book of Optics became a standard text in optics for centuries, shaping the course of scientific inquiry. Ibn al Haytham drew inspiration from a variety of sources, including the works of Euclid, Ptolemy, and Aristotle. He critically examined these sources, identifying their strengths and weaknesses. He subjected their claims to experimental verification, rejecting those that did not stand up to empirical testing. His ability to synthesize existing knowledge with his own original observations and experiments are testament to his intellectual genius. The influence of the Book of Optics extends far beyond the realm of optics. Ibn al Haytham's emphasis on the scientific method had a profound impact on the development of science as a whole. His insistence on empirical observation, mathematical analysis, and logical deduction helped to establish a new standard for scientific inquiry. His work served as a model for later scientists seeking to understand the natural world through systematic investigation. Ibn al Haytham's legacy lives on in the modern scientific enterprise, a testament to his enduring contribution to human knowledge. He was brilliant and prolific. In conclusion, the Book of Optics represents a towering achievement in the history of science. Ibn al Haytham's meticulous investigation of vision and light, his rejection of the emission theory, his systematic application of the scientific method, and his profound influence on later scientists and scholars all contribute to his status as one of the greatest scientists of all time. The Book of Optics stands as a reminder of the power of human curiosity and the importance of empirical observation in unraveling the mysteries of the natural world. His groundbreaking work reshaped our comprehension of light and vision, leaving an indelible mark on the trajectory of scientific thought, a contribution whose significance continues to resonate today.
We really appreciate you tuning into this AI-powered presentation. Our goal is to push the boundaries of AI in content creation, and your input is invaluable. If there's a particular subject you'd like to see us tackle next, or if you have suggestions on how we could fine-tune our AI's creative prompts, please don't hesitate to leave your ideas in the comments section. We're excited to bring you more unique content very soon.